This is the binary search problem. Given the sorted array, return the index of the target element. We initialize the start and end pointers and traversing from both the ends. Every time we calculate the mid, and this is the formula. When the mid is equal to the target, we return the mid index. Otherwise, if it is target is smaller, look up into the left side and update the end. Otherwise, look up on the right side and update the start. At the end, start index would be the element index of the target element. Binary search, that's why the time complexity is O of log n. We always cut down the half elements, and space complexity is O of 1, as we do not need any extra space. In this variation of binary search problem, given the rotated sorted array, we have to find the smallest minimum element. Here we start from the traverse from the left and right side, that is with the start and end pointer. We quickly check if the first element, start element, is less than the end element, then there itself return the number at the start, element at the start. Otherwise, calculate the mid. Now if element at the mid is greater than element at the end, then update the start pointer. If element at the mid is less than the element at the end, then update the end pointer. If they both are same and duplicates are allowed in the array, we cannot determine anything. That's why reduce the end pointer. Otherwise, update the end pointer to the mid -1 for the unique elements. At the end, return the element at the start position. As it is binary search, we are cutting down the half elements of the input, so the time complexity is of log n and no any extra space used, so space complexity is of 1. In this variation of binary search problem, we have to guess the number. So for that we start from the start pointer and the end pointer until the end pointer will point to the given number n. Now we calculate the mid. If the we with the helper guess function, we will get the value. If the value is equal to 0, the guess is equal to the number, so we return the mid index. If the value is -1, that is guess is less than the number, we search on the left side, update the end pointer. Otherwise, we search on the right side, update the start pointer to mid +1. At the end, if not found, then it return -1. By its binary search, so the time complexity is log n and no any extra space used, so space complexity is of 1. In this variation of binary search problem, we have to find the first bad version. For that, n is given. We traverse from 1 to n from both the sides, start pointer and the end pointer. We calculate the mid. If mid is the bad version, then the first bad version will lie on the left side, so update the end pointer. If not, then it lies on the right side, so update the start pointer. At the end, return the start. It's the binary search, time complexity is log n and the space complexity is of 1. In this variation of binary search problem, we have to search an given target in the rotated sorted array. So for this, we start from left and right side, start and end pointer. The array may contain duplicates, so move the start pointer until the sequential elements are same. Similarly, from the end, we move the end pointer until the sequential elements are same. Now we calculate the mid. Once if the element at the mid is equal to the target, then we return the mid, or we return true if it is found. Otherwise, we look for the sorted array. If left is sorted, we check if the target is between the left bounds. Otherwise, look on the right side. If right is sorted, we check if the target is between the right bounds. Otherwise, we move again back to the left side. If nothing else works, then just we have to increment the start pointer. At the end, we have not found the element, so we will return -1. As this is binary search, half of the elements we are eliminating, its log n complexity. No extra space is used, so the space complexity is O of 1.